Okay, so this presentation discusses cluster analysis and will help you to complete homework 10 and 11. So what is cluster analysis? Cluster analysis is an effective and efficient method of executing market segmentation to identify subgroups of customers to help improve business and marketing decisions and therefore performance. So to discuss cluster analysis, we first have to look at the basic ideas behind it. A market is a group of people who gather to buy and sell, and within each market, there are subgroups with different needs. So, market segmentation lets companies divide consumer and business markets into smaller groups with shared characteristics. Segmenting a market using shared traits or characteristics is referred to as cluster analysis. Cluster analysis uses algorithms to explore data relationships, then develop smaller groups from larger populations, and these insights are used to improve marketing strategies, better allocate resources, and gauge new product development, and select the most receptive test markets. Clustering algorithms identify groups with similar traits. American Express segmented their market into the most loyal customers, make features tailored to them, and increase their market share. Car companies also use segmentation to target specific consumers. Best Buy spent 50 million remodeling stores and training staff according to identified consumer segments, labeled Buzz, Jill, and Barry, to enhance the in-store customer experience that resulted in a 10% growth in sales. However, I don't like shopping at Best Buy, so clearly I was not one of the three model types. Not to mention their prices are always more than what you can pay online. So anyways, clustering enables marketers to identify hidden patterns and structures, and by assigning names and definitions to each cluster, the companies provide meaning to the results. Distinguishing meaningful clusters from the larger population allows companies to understand and respond to customer engagement, activities, and buying behavior. So how does a cluster analysis function? Cluster analysis organizes data into two or more similar groups that share characteristics. Within the cluster, they have homogeneity and or similarities, and between the groups, there is heterogeneity or dissimilar qualities. The similarity between the groups is calculated to provide the distance between the groups. We'll discuss several ways to examine this in this presentation, but smaller distances indicate more similarity between groups. So no established dependent variable is specified with a cluster analysis, and as such, it is considered an unsupervised technique. The goal of cluster analysis is to model the underlying structure and distribution of characteristics in the data to separate a data set into homogeneous subgroups. So this visualization shows an example of cluster analysis and how they can be classified visually. So you can see it's a three-dimensional rendering, uh, three-dimensional scatter plot. So the distance from the store, number of purchases, and customer income are the three independent variables. And then we segment these three people, probably the, what is it, Buzz, Jill, and Bob, or whatever the third name was, are the three groups. And then they can develop different marketing campaigns to each of those groups based on the clustering. What are the types of cluster analysis? The most common techniques for cluster analysis is something called k-means clustering and hierarchical clustering. K-means clustering uses the mean value data point in the cluster and minimizes the distance to the individual observations. It is efficient to use with large sample sizes. The first step in a k-means clustering algorithm is to determine the initial k cluster. It is best to begin with a data set in which each variable is measured the same. Next, the observations are randomly assigned, and the cluster centroids are determined, and the observations reassigned. Following that the cluster centroids are recalculated and the observations are reassigned, the results are examined with the best number of different homogeneous groups, chosen based on what leads to the most effective strategy. An overall group mean is calculated, and observations are assigned to the group they are closest to in terms of their characteristics. Cluster evaluation, something called the elbow chart. The chart shows a line that can be evaluated to reduce cluster error. We will look more at these techniques in class, but this is just to provide some small exposure before we cover it. But I mean, generally, the more clusters you have, the lower the error, and that's the goal. And what we want to do is modify the clustering algorithm to where we can get fewer numbers of clusters, because from a marketing standpoint, the fewer number of marketing campaigns you have to develop based on each cluster, the better. The silhouette score can also be used for cluster evaluation. It is calculated after the cluster algorithm has assigned each observation to a cluster to determine the average distance between each observation in the cluster and the cluster centroid. Typical silhouette score ranges from 1 to -1. K-means issues to remember. Some issues with k-means clustering to keep in mind include that to obtain the most accurate results, you must begin with data that has been standardized using z-scores or min-max, and that it can only be applied to numerical data. So that presents a little bit of a problem if you have categorical data or ordinal data that, doesn't exactly fit correctly. What are other types of clustering algorithms? We have hierarchical clustering. So another widely used clustering method is this hierarchical clustering, in which individual observations are combined into subgroups using a measure of the distance between the observations. This is commonly done with either agglomerative clustering or divisive clustering. Agglomerative clustering is a bottom-up approach, and each observation is initially considered a separate cluster. At the end of the agglomerative clustering approach process, all observations are included in a single cluster. Divisive clustering is a top-down approach, and the process starts with a single cluster of 100 observations and ends with 100 different clusters. Initially, all observations are assigned to a single cluster. So there are many methods for measuring similarity in hierarchical clustering. You can use the Euclidean method. The distance is measured as the true straight line distance between 2 points. In the Manhattan method, the distance between 2 points is not straight, but rather a path with right turns as if walking on a city grid, and thus this distance measurement is called the city block. The Euclidean or Manhattan methods are most often used when numerical data or numerical variables are analyzed. The matching method measures the similarity between two observations with values that represent the minimum difference between 2 points. And the Jacquard's approach measures the similarity between two observations based on how dissimilar two observations are from each other. To measure similarity or dissimilarity, a linkage criterion can be used to capture the distance between the resulting clusters. With complete linkage, similarity is defined by the maximum distance between observations in two different clusters. Using single linkage, similarity is defined by the shortest distance from an object in a cluster to an object from another cluster. And with average linkage, similarity is defined by the group average of observations from one cluster to all observations from another cluster. Another method that can be used to determine or to measure distances in hierarchical clustering is called Ward's method. Ward's method is the measure of the sum of squares within the cluster summed over all variables. This method selects two clusters to combine by determining which combination of clusters minimizes the within cluster sum of squares for all clusters across all the separate clusters. All four measurement approaches can be illustrated with this dendrogram, as shown here. However, identifying the correct number of clusters using a dendrogram is rather subjective. Hierarchical clustering issues to remember. So just as with k-means clustering, hierarchical clustering has some issues to remember. First, hierarchical clustering can be applied to both categorical and numerical data and should be implemented with standardized data using z-scores or min-max. Well, thought I had more on that one. So this is the end of the presentation on cluster analysis. This presentation should be used to help you with homework 10 and 11.